use a simple definition for acids and bases. An acid is a proton donor. A base is a proton acceptor. There are other definitions for acids and bases, but we'll keep it simple for now. In an acid-base reaction, both are always present. If something is acting like an acid, then something else is acting like a base. If something else is acting like a base, then something is acting like an acid. Here is an acid. It reacts with water. Water is the base. It accepts the proton, becomes H3O. The acid becomes A-. This is the conjugate acid, conjugate base. When something acts like an acid, the remnants are the conjugate base. When something on the left reacts like a base, it becomes a conjugate acid. Let's start with the base. This time water will act like an acid. It's going to donate a proton. The base is going to become a conjugate acid, and water will become a conjugate base. Here water displayed abilities to act as both an acid and a base. That is something that would be called amphoteric. Amphoteric is used to describe something that acts as both an acid and a base easily. Many things, even things that are strong acids, can act like bases. That's the whole point of that, is to show that acid and base definitions are not static. It really depends on where they are. Even something that is generally a relatively strong acid can act like a base if it's with something that's an even stronger an acid, something that's a very strong acid. It could potentially make that acid that is weaker function as a base. The Ka and Kb values are the constants for acids and bases, and they are the same as chemical equilibria, where there are products and reactants and a particular ratio that at a set temperature, pressure, conditions, the rest, has a constant that it always reaches. And the constant for the acid and the base depend on those set of conditions, and they can be calculated. And whatever they are, that is what they always are at that particular temperature. This ratio of products to reactants. Things that are strong acids will have high Ka values, and things that are strong bases will have high Kb values. The strength of an acid or a base is going to be determined by the concentration of hydrogen and OH for a base. Hydrogen for acid, OH for a base. So things that are strong acids, like HCl, dissociate very well. And that is another way to think of Kas, the measure of an acid's ability to dissociate in an aqueous environment. HCl, when it's put in water, dissociates nearly completely into hydrogen and chlorine ions. Similarly, NaOH is a strong base, and it dissociates almost completely into Na and OH ions. That's why the Kb and Ka values are high, because this number is almost non-existent in the cases of a strong acid or strong base. In the case of a weak acid or weak base, then the Ka values are relatively small. A dissociation for something like acetic acid might be 2 to 5%. 2 to 5% of this will dissociate into this. So the Ka values will be small. And those kinds of problems can be tackled in the exact same way that chemical equilibrium problems are approached, because it's the same thing. Really what a acid-base equilibrium is a special kind of chemical equilibrium reaction where some protons are being shuffled back and forth, essentially. It's just a special kind of equilibrium problem. But the way to approach them are exactly the same. Treat it as if it were not an equilibrium, or not an acid-base reaction, just any other problem, and the results will be the same. One common way of describing the strength of an acid, the most common way, is using the pH scale. The pH scale goes from 0 to 14. 0 being acidic, 14 being basic. There's also the pOH scale, which also goes from 0 to 14, but in the opposite direction. 0 being a base, and 14 being an acid. It is also important to note that it is possible to get a negative pH or pOH, but it's only in cases where on the pH scale the concentration of H is greater than 1, which in all honesty doesn't occur so incredibly often in most cases. In cases of organic chemistry and various other fields, maybe in different industries the pH will be very high, but it's unusual to run into an acid that concentrated. So normally it's thought of being 0 to 14, but know that it can be a negative number. You're not going crazy. Another useful thing of the pH scale is that it allows conversions, easy conversions from Ka to Kb values. If I have a Kb value and I want to know its pH or its Ka value, what I can use I can use 14 is equal to pH plus pOH to very quickly convert from Kb's and Kas.